Welcome to qnawire.
Here we have a bar with wheels on both ends. The bar is 1.2 meters long. The right wheel is moving to the right at 3 meters per second. The left wheel is moving down a curved ramp that has a circular radius of 0.5 meters. And it's about 60 degrees up the ramp right now. We want to know how fast B is moving. And to do that, we're going to look at a little bit of geometry quick. The total height here is 0.5 meters. So the height of point B will just be 0.5 meters minus the part of this triangle up top, which will be 0.5 then minus 0.5 times the sine of 30 degrees. So height of B is 0.5 minus 0.5 times sine of 30 degrees. And we'll just remember that for a second. So we'd like to calculate then the angle that this ramp rises here. And we can do that looking at the sine of that angle, which would equal that height. So that's 0.5 minus 0.5 times the sine of 30 degrees, divided out by the length of the bar. So it's just simple sine function. And we find that beta, based on this geometry, is just 12.02 degrees. We can write our velocities in vector notation. VA equals 3 meters per second in the i-hat direction. VB, on the other hand, will be whatever the magnitude of VB is, times the sine of 30 degrees in the i-hat direction, minus the cosine of 30 degrees in the j-hat direction. And this angle just comes from our current geometry here. That this top angle here is 30 degrees. And that it has to be moving then down the ramp. We can then write our omega, so this rotation in the k-hat direction. We also want to look at the position of B with respect to A. We know the length there is L, but that's not going to be good enough for us. We need to take then the vector B minus vector A. If we take the origin to be point A, it'll make our life a lot simpler. And then RB is just simply 1.2 times negative cosine of beta in the i-hat direction plus the sine of beta in the j-hat direction. And this is all in meters. We can then find the velocity of B from the velocity of A plus the velocity of B about A, where we get the velocity of B about A by taking R cross omega. Omega cross R. When we look at this, then the left side of the equation will have some i-hats and j-hats, and the right side will have some i-hats and j-hats. So I'm going to write out the right side first here before we compare just the i-hats and j-hats. So the right side will have in the i-hat portion a 3 i-hat from VA and from VB about A, which we get from the omega cross R. We get a minus 0.25 omega I hat and a minus 1.17 omega j hat. So then we can compare our I hats and j hats. So for the I hat portions, we have VB times the sine of that 30 degrees equals 3 minus 0.25 omega. We don't know VB yet, or omega, so we're not quite ready to solve for anything here. If we compare just the j hat terms, so with j hat, we have the, so not an equal sign here, but with the j hats, we have a negative VB cosine of 30 degrees equals negative 1.17 omega. And we have a nice system of equations here we can use to solve for either VB or omega. I'm going to solve for omega first here. So if I divide these two equations, the VBs will cancel out, and I have a negative tangent of 30 degrees equals 3 minus 0.25 omega over negative 1.17 omega. So those negative signs can cancel out. I can do some algebra to find that omega is 3.23 radians per second. Once we find omega, we can go ahead and put that back into our equation to find what VB is. And the easiest equation is going to be our j hat equation, which I will underline here in green real quick. So that we find that VB equals 1.17 omega over the cosine of 30 degrees, where we just found omega, and we find that the velocity is 4.38 meters per second. And one more quick thing about omega, I did not say what direction that is, but since B is lowering and A is staying the same, that means that the rotation must be counterclockwise. So CCW.